Alrighty tighty folks, welcome back to the channel. Today on But It Runs, I'm going to be modding the ECU in the Civic so that I can add a pre-filter intake temperature sensor so I can see the heating effects into the intake. Here in just a second, I'll be talking with a buddy of mine on a phone call explaining all of this, so why don't we just get into it?
Sweet. So I'm trying to add a secondary intake temperature sensor pre-filter, so I know how much the air is heating up from the time when it enters the airbox to the time that it enters the intake manifold. I'm trying to get as close to the temperature heating difference as I can to inside the cylinder with the available hardware. Okay, so the current ECU, this is called, in all of the aftermarket and the racing Honda guys documentation, this is called B6. You can see here it's actually B14. And of course the stream updates a few seconds later, so you'll see it will kind of go slowish because of that. So B14 is B6 in the tuning program and in the wire harness pinouts that you find online. And I've had to figure this stuff out the hard way. So, the circuit coming in, well, there's two things. The circuit coming in to B6 right now is the wideband. I have a couple of options. I can take the temperature sensor, the temperature sensor number 2 pre-filter, plumb it into B14, and match the circuit at B14 to what is at D4 for the intake temperature sensor, which is this voltage divider here, and then it comes down, the schematic's poorly written, mind you, it comes down here and actually goes into U6, a multiplexer. Whatever voltage that pin gets analog, there's an A to D converter inside the multiplexer. It sends it out to the MCU, the main calculator unit, as digital data, right? So you're going to have some error in that signal. The other option is to go down here to D17, which is EGR position. My car doesn't have an EGR system. It's not a California model. I don't plan on putting an EGR system ever in this car. So I can butcher this circuit on the PCB to make it work. Looking at it, what I would have to do is RM2 is a resistor. It's one of those like flat pack resistor blocks. You can see all the different connections to the resistors to each other inside there. So what I would end up having to do is just cut D17, that trace from pin 4 and RM2, cut it, strip it back on the PCB, solder a green wire to it, bring it over to 5, replace it with this, so that's a 5 volt, I believe. So 5 volt, 1500 ohm, 6800 ohm, and then into the signal. So replicate that kind of voltage divider into what would be either U5 or the B14 signal, or straight into the MCU or the EGR signal. I don't know. So the tuning program, I can look at the EGR signal and I can set it in the program to redefine the values. So the voltage, I can give it a table. This voltage means this voltage means this voltage means this. So I can see that in the thing. So I don't think it would be any different. My first question is, through a multiplexer, do you remember anything about because the A to D converter in the MCU is going to be next to identical as the multiplexer, I would assume. They're the same era of IC, so I assume that they're going to be fairly similar in design. Do you think that's a fair assumption to make?
Yeah, because I would say multiplexer is a multiplexer.
Right. Because
You're
it's
gonna want to. I mean, based on the parts, they're obviously gonna have different thresholds because they're made of different material.
right.
So that's the only thing I'd say you really got to look at is that little bit of difference. But a multiplexer is a multiplexer.
Right, and the signal's going to be like, it's going to be 0.015 volts per step or something. Right, so it's like, what is your error going to be? It's on an automotive environment with a 5-volt signal and a 12-volt powered A to D. Your resolution is more than high. Your resolution is far higher than what the engine actually requires to run correctly. Coming at me. Ooh. I know what I can do.
Slightly different circuits. The V14 has a 1K series resistor into the multiplexer. Not 100% sure why. V14 is not normal. So I don't know that.
Okay.
There's a voltage
Mr. Lippity Lappity Lappity Lapese top. Mr. Blue top.
1800.
Mr. Azul top. Azula.
10 of 2.
I did always find it funny that they called her Azula, but she never wore any blue. I mean, I realized it was primarily at me. Ooh!
It's a voltage divider.
I know what I can do.
That line in the multiplexer at a specific value, obviously. I imagine that's just because you don't want it floating, otherwise it gives you spurious data.
Okay.
If I remove
Mr. Lippity Lappity Lappity Lapese top. Mr. Blue top. Mr. Azul top. Azula.
R3,
I did always find it funny that they called her Azula,
I remove R2 completely.
but she never wore any blue.
6800. R3,
I mean, I realized it was
that will
primarily American writers,
electrically
and
identical to the intake difference.
they're not necessarily ones for
Easy peasy.
the hidden gems, per se.
I would have to move the wideband signal to another pin. Which I guess.
What we're going to do, see, since OBS does not like
EGR, I could just cut it.
trying to encode
Yeah, EGR.
while we are in the midst of decode,
That resistor thing, you just run it straight to the ECU.
I'm going to get Mr. Lippity Lappity Top Lenovo coming at me. Ooh! I know what I can do. Ba-da-ba-ba-da-ba.
There we go. Internal memory.
Okay. Mr. Lippity Lappity Lappity Lapese top.
And
Mr.
that's
Blue
what I
top.
decided to do. So we're putting
Mr.
the intake
Azul
temperature
top.
sensor on the B6
Azul.
input, which is
I did always find it funny.
B14 according to the PCB and the Honda engineers who designed the thing in the first place. And I decided to do that because that would give me effectively an identical circuit, so tuning the thing would be a little bit simpler in the end. Here you can see I'm taking a pick, and I use the pick and the razor blade there to take the solder mask off, and then I cut the trace just the tiniest little bit and scraped it off with the pick. The gouge in the PCB where the trace used to be is probably a millimeter, maybe a millimeter and a half wide. It's very, very small. If I ever need to fix it in the future, it'll be super easy to repair it.
You want to check? You got continuity and lamp. We want to check pin 4, which is this guy, to the corresponding pin on the ECU, which is that guy.
Alrighty, teddy folks.
And then we're going to check here.
I was going to start a little bit early today. Got up a little bit earlier.
That is
Did some
connected.
stuff a little bit earlier. Brushed my teeth a little bit earlier. And came out here a little bit earlier. turned the camera on a little bit earlier. Then I had to plug a cable in. I had to move the Civic back. There's a night to close the garage door, and I gotta pull it all the way up against
We successfully cut
bench
the
here.
directions. Now, what I need
So,
to do is
I'm starting right on time today. I was gonna start early to
The
make
reason
up
I'm
for
not
yesterday,
picking
where I
up
started
a
late.
bunch
You
of
know,
trays, I'm just cutting
balance
out
of the
some
universe
sort
and everything.
is if I ever
But
need to fix it in the future, small effect.
it didn't happen.
Put a little piece of green wire down
Apparently.
there, solder straight over it, put some solder mask on it.
So, I got a couple of things I gotta do today, or I don't have to do anything. I really don't have to do anything.
Which is going to be
Got
fun.
a couple
Quit
of
taking
things
my
I want
lines.
to get done today. Some of them are inside in the house, so that'll be after the stream. One of them I'm going to be
I'm
contemplating
actually going to do a little bit of
how I might get it done and put it in the stream.
on the top side here because we're
I don't know.
a little bit dirty.
We'll burn that bridge when we get to it, right? Hoist. I want to go.
Which I promptly cut out of the
Send a
video.
link to-
You can see I'm cutting the other trace on pin 5 here. It runs only across the top of the board where all the components are placed, so it was a little bit more difficult, A, to follow, because it actually ran underneath the silk screen at one point over there by that other resistor pack. That was fun. But I found it, and I isolated it, and I did the same thing where I gouged a little piece of the copper out there, and then we cleaned it all up, easy peasy. Check to make sure it's not connected from one end to the other. You know, make sure I didn't forget to remove a small piece of conductor there. Of course, me being blind and having poor lighting in the garage, it's time for a flashlight. And the magnifier on my phone because I don't have a microscope. Microscope would have made this infinitely easier, by the way. Wink, wink, hint, hint. Applied a little bit of hot glue to the wire mod so that, high vibrational environment in an automobile, it wouldn't just fall off, break the solder, I lose a sensor, risk damaging the board via a short or some other such thing. Now, that first segment was me doing an experiment on a test ECU that I have that's already been damaged. The MCU doesn't work. You see, now, here we're taking apart the ECU that actually runs a Civic, and I've got the daemon in there and the data cable that I use to connect to the computer. So now that I was able to successfully apply the mods to the spare ECU, the test ECU, figured it's time to do it to the real thing. Got the parts in there. It's really funny. I ordered 1,000 of each of those resistors. One 1500, one 6800 resistor. One of them is 1/8 watt and one of them is 1/4 watt. Apparently I didn't pay enough attention when I was placing the order. Doesn't matter. It's microamps that move through these things anyway, so it's not a big deal. Come to find out, I was going to order 100 or 20 or 10 even. After shipping, and the price breaks for ordering in bulk, it was actually cheaper, not cheaper by value, but actually numerically cheaper for me to order 1,000 of each of them. It was going to be $38 to order 100 of each, and it came out to $28 to order 1,000 of each after shipping. So now I've got a bunch of extra resistors. Because these resistors are a little bit larger than those that were originally installed in the ECU, I had to do a different thing. Instead of laying them on the board, we fold them over like that. Not a problem. Resistors have been installed that way on PCBs for 50 years. So, put him in there, get him soldered in, get everything going. And I did have commentary from the stream in which I pulled this, but the audio quality wasn't very good, so I ended up silencing it. You can see resistor soldered in there, not very good solders, and not very good image because this is a VOD pool instead of actually recording it like I should have. Stupid. And then I had to flip the camera because it was backwards from when I was doing something before, and I forgot to flip it around again. I know what I'm doing. And doing R1 was a real pain because R1 connects to a ground plane. And let me tell you, folks, ground planes take a lot of heat. A lot of times you end up damaging pads because they have thermals, which means the pad itself can't take as much heat. Well, the adhesive underneath the pad itself can't take as much heat as the ground plane is going to try to soak out of it when you're trying to apply the solder. So I ended up doing a little bit of a cheese, which I don't think I caught on camera, where you take a really, really small something or another. I use picks from Harbor Freight. They have these really tiny, like, dental picks. And you get the solder hot enough that it starts to melt, but it's not hot enough it'll flow into the solder wick there. And you just slowly take your pick through the through hole to leave a hole such that you can just put the component in. It's an old school trick. It's not very fun, and it's not very good to do. But sometimes when needs must, we do those things. And I did try initially to use a surface mount resistor. I have a bunch of 0402 surface mount resistors. And I did try to use a surface mount resistor in the middle of the wire there. Focus. Thank you. And I couldn't get a good enough mechanical connection that I was satisfied. Every time you tried to bend the wire, it felt like it was just going to come right off the resistor. So I figured I'd go with a surface mount resistor. I've got plenty. It's not a big deal. And the wire's bulky anyway. I didn't end up using a green wire mod. I just used some 24 gauge solid core wire that I had laying around for the wire mod. And it ended up coming out just fine. There's heat shrink over the solder on the wire mod where the resistor sits. So there's little to no chance of causing a short via vibration. You can see we're doing the trace cutting on the main ECU right there. Pin number 4 in RM2 and then pin number 5 in RM2. You can see there I'm just pulling back the solder mask a little bit so that I could get down to the trace. Tell you what, that magnifier on my phone is kind of a lifesaver for this mod. I could actually see what I was doing. It's not the greatest solution, but it does a thing. If it's stupid but it works, it ain't stupid, right? Then we do the same thing where we test and make sure we've broken those connections to their endpoints, which is easy enough. If you think this is either dumb or fun, either way, drop a like, subscribe to the channel. This is the kind of stuff I like to do, so there's probably going to be some more coming of it. Then I am using the spare ECU wire mod as my guide, so I don't have to try to guess at which way I need to route the thing again. And it would have been nice if I'd have been able to get a clean shot of the wire mod, but somehow I've lost that footage. I have no idea where it went. And I'm far too lazy to pull the ECU back out and take pictures of it. So, if you guys want to see that, let me know in the comments, and I'll make it a special point just for you guys to do that. If it doesn't matter, then it's not going to happen. It's just going to sit in there. It's fine. It's fine. And it's a good thing the rear case doesn't actually sit up against the PCB. Like, there's no, what do you call those things? There's no inserts on the back case. It's just empty space. So we can stick this wire mod in here, no problem. I think if you squint real hard, you can also see the capacitor that I installed on that line in place of RM2 to bypass any AC signal we might get, any noise we might get from the engine bay and the wire run, so that we get as clean a DC signal as we can without slowing down the response. That's always the key with filtering elements, right? Is you want to get as close to accurate reproduction at the far end, at the back end, as you can without distorting your input signal in any way. And of course we get the hot glue gun. Easy peasy. Make sure it doesn't vibrate around and break nothing. Put a little bit of glue on that capacitor. And putting it all back together. This video was long enough just doing this with the time lapse, showing you just what it takes really to mod an ECU. It's the same thing for modding any kind of circuitry, because they're all PCBs, they're all just components and ICs and conductors and insulators and etc., etc. Newer boards tend to be a lot more dense, and they use smaller components, so it is getting a little bit harder. But if you got good equipment, it doesn't really matter. You can even do it with crappy equipment, as is shown here. This ECU is actually kind of really fancy for its time, and it's still pretty easy to work on. So if you guys want to see a video about the end result of this, my camera actually overheated while I was trying to film it, so I didn't get that footage. And like I said, the video was long enough without it. So if you guys want to see that, let me know in the comments, and I'll make a whole other video just about control systems and sensors and everything else. As always, if you liked it, don't forget to like and subscribe. And whatever your project is, crank it and rip it. We'll see you in the next one.